Hello, my name is Shengguang. I would like to give a basic introduction to the answers to my interview questions. Okay, let me share. Yeah, I have shared my screen. Let me share my screen. Okay. Okay, so this is the task. It need to implement a simple match engine that can execute limit and market orders. And it should have optimal store of order book, which can index the orders. And this should be the most interesting part. And it should have a rollback feature. You can roll back the orders to the old state. It cannot just duplicate the order book in memory and switch between them because it will waste a lot of memory to save what the order states. Okay, I have committed my solution to my GitHub repo. It's a public repo, so everyone can check it. It's over here. Shengguang Xiao simple match engine. Yeah, I will share it in the email. Okay, let's go to the code. I have a code in my local. So this is the simple engine. Okay, this is developed in Rust. So Rust, we use the cargo to manage the package. I give the package a match engine. Okay, so let's go to the basic types. Let's go to the basic primitives. We have the asset. It's basically a very simple enum to define the asset. Yeah, and we have order data type. Have order ID asset, which is set by what asset means buy or sell. Basically, B that will ask price, quantity, time step, match time step. Order type can have market and limit order. Okay, we have orders. This orders is a help function to help us to create the order request. Basically, we can support the market order, limit order, cancel order, three types. Yeah, this is the basic three order request features. So this is some help function to help us to create the orders. And let's go to the order book. The order book. Let's go to we have order queue. So this order queue is the most interesting part. It's customized order queue data struct. So it is defining order queue to RS. So we have an index queue. We use a binary heap to save the order index. So basically the order index is used to for the binary heap. It will always save the top one on the top, so we can every time we can get the top one. So order index it is ordered basically by price. If the price is the same, it is by time step. So for the order index, when we compile, it is the compile type is basically different based on the order side. So for the bid, if the price is higher, then it will be on the top. Okay. So price is higher, it will be on the top. So for the ask, the price is lower, it will be on the top. So we always match the highest bid with the lowest ask. Yeah, so basically the highest buy order match with the lowest sell order. Okay, this is the order index. So order index is just not the full order data struct. It's a partial, so we can save the memory. And we have another one is a map. hash map to save the order and ID and the order. So we use a hash map because hash map is very easy to look up, very easy to insert and delete. So we use this combined to do the order queue. So this order queue we can support this is create a new order queue, and the peak basically we get the one on the top, and the pop is where after we match we'll pop up the top one. This is insert new one. Force insert is used for when we roll back, we will override. Let's say it's for partial matched order, so we need to force restore it to the old state. It's only used for restore. This is for cancel order. Yeah, modify current order is after partial match. We modify the order. This is rollback. So for rollback, if we only retain the to our old state, if the we only retain the time step less than the target time step, so we restore to the old state. Rebuild the index. After we roll back, we need to rebuild the index from the orders to build the battery heap. Okay, this is some test to test this order queue. Okay, this order queue, for example, we have a queue for beads. For example, beads 3002, 3001, and 30,003, 30,001, 30,002. So when we pop, after we build the order queue, when we pop, the first one should be order 3 because it has the highest price, and then 1, and then 2. So it's 3, 1, 3, 1, 2. Let's see how there's a pop. So when we pop is 3, 1, 2. So it the highest one pop out first, the second, the last. Yeah. So this is some unit test to test the order queue. Let's go back to the order book. We have a bid queue and ask queue. This sequence basically generate order ID for the new order. So when we submit a new order, we automatically generate an order ID for it. This is the history order. So basically, after it is matched or cancelled or partially matched, it will be saved in the history order. For the history order, it's used to restore the order book to older state. So we can we don't need to save all the old order states into the memory. Instead, we just roll back the orders in the order history. Okay. So in this order book, we have we created this new order book, process orders. So process market order. So market order, we always try to, when the market order comes in, we will process it. We try to match it. So for the for the market order, we will find the opposite order side. If it has order, then we just try to match it, order to the order matching. So do the order matching if this order is smaller than the operator order. So basically it is a partial match. So we need to modify. We will save the operator order before modify, we need to save it to the history so we can restore it in case. Okay. We need to modify the current order because it's a partial match. We will change the quantity to the original quantity minus the matched quantity. Now it's the quantity left. Okay. So if it's this quantity is larger than the opposite order, so the opposite order is fully matched. So it will be also put it in the history, and we will also pop it out. We'll pop it out from the opposite queue. If it's exactly match, basically the quantity is exactly matched with the opposite side, then it is a fully filled. It will return. So we will also pop it from the opposite side. Okay, this is the order book. Let's this is how to process them. Process the bucket order. Process the limit order is a little bit different. We first need to check the order can be matched. basically the bid price. If it's a bid, and the bid price must larger than the opposite side price. We need to pick the opposite. If it's larger, then we can match. If it is ask, then the price, the ask price should be if it's sell, basically the order should be lower than the bid price, then we can match. Basically, we need the order book to be crossed. Then we can match because this is a simple engine. We have this simple logic. Yeah, if it can be matched, then we do a order matching. Yeah, same as market order. If the order not match complete, then we matched, partial match, then we continue match the left until it cannot be matched. Okay, if it cannot be matched, so basically the order book is not crossed, then we just store it to the order book. Okay, for the cancel order is very simple. We just put it to the cancel, and then we save it to the order history. Okay, this is the order matching, just like we introduced. Okay, and then we have rollback. So basically, for the rollback, we need to roll back to an older time step. For the older time step, we need to first check the history order, what have been matched. So we need to restore it to the order book. So we loop through the history order, and then we insert it back to the order book again. If it's a partial match, we restore it to the old state. So we first insert to the history order back. And there are maybe some new added order. So we also need to roll back the bid queue and the ask queue. Just now introduce this rollback function already. Yeah, so it only retain the order and the target time step. And then we need to rebuild the index. Okay, this is rollback. It's basically the function match, rollback, destruct, and then let's go to the test. Yeah, so we have this test. So in this module, we use the order book, the data structs, and use some thread and the time features. So basically some order book word check and the market order partial match. Yeah, this is some order match. One empty orders and the exact match. Cancel order, get the current spread. Build the order book for cancel. So test the rollback order book after match. So basically after match, some order we build in this function. We build the order book. We have two limit order. One is bid 3,000 and 30,000 and 30,010 BTC. Okay, this because they are not cross, so they will be saved in the order book. So now I submit after a while, snip for 2 seconds. I submit a market order to match with them. Sell order, this is bid match with the sell order 0.8. So after match, you only have 0.2 matched. So in this test, you can see only 0.2 left. Okay, let's roll back. After roll back, it will become 1.0, the old state. Yeah. Okay, so this is after cancel. We also have the after cancel the order tree is done. We cannot get it. So after roll back, we can get it again. Okay, so basically this is the introduction, how to build it. I use cargo. So cargo build, if you build a release, cargo, that's just build the release. So you know I build the project. How to test, cargo test. So you know I run what you did test in the test folder. Yeah, so work passed. Yeah, thanks. Yeah, that's okay. That's the rough idea, basic idea of how this task Yeah, you just still have something need to improve, especially the asset is very simple. We don't support complex assets. Yeah. Okay, that's it. Thanks.